Assalamualaikum and hi everyone, I am Muhammad Azrizan and we are from Group 1E, and today we are going to present our final project which entitled Anaerobic Sequencing Batch Reactor in Biohydrogen Production from Palm Oil Mill Effluent, or also called as POME. Me and myself, I will be talking about the project background and also the objectives of this study. Meanwhile, my other group mate will be talking about the other part of this presentation. So without further ado, I will start our presentation with the project background. So as we all know, fossil fuel is the primary energy source in this world, and the burning of fossil fuels in the power production contributed to the increment of carbon dioxide emission in this world. Therefore, it is crucial for us to replace fossil fuels in order to reduce the environmental impact, and one of the alternatives that is available now is that by using biomass from agricultural waste as renewable energy. So palm oil is one of the biggest industries in this country, in Malaysia, and every year at least 44 million tons of POME is produced in this country. So POME is actually defined as a highly contaminated waste produced from the oil extraction process, and considering the number of POME produced in this country annually, it can be used as an alternative to replace fossil fuels in the power production industries. So this project focuses on the utilization of POME to produce biomass-derived hydrogen, as it offers various advantages which can minimize the impact of power production to the environment. So in this study, biohydrogen is produced from raw POME by using dark fermentation method in two-stage anaerobic sequencing batch reactor system. ASBR is chosen as it can dissociate the solid retention time from the hydraulic retention time, and at the same time maintaining a high biomass concentration. So moving on to the objectives of this project. The objectives of this project is that this study aims to determine the hydrogen production from POME using two-stage ASBR system by using thermophilic and mesophilic condition. Besides, this study also focuses on evaluating the effect of HRT, which is the hydraulic retention time, on the hydrogen yield, where the system is run continuously in ASBR mode and HRT is being manipulated.
Hello, I am Elan Han, and today I would like to talk about the market analysis. Market analysis is conducted to identify the root causes and available potential market for the concept. There are several aspects that should be taken into considerations when assess a market analysis. The first aspect is the customer analysis. The largest consumer of the hydrogens were found to be Asia, in which China alone accounted for one-third of the total consumption rate, then followed by Middle East, Europe, and United States. For developing countries like Malaysia, although the use of biohydrogens to replace fossil fuel is only started to gain its popularity lately, however, according to the prediction made, Malaysia will have the largest mineral output growth of 5.02% by the year 2017 to 2040 compared to Japan, India, China, and Korea. The second aspect is the market demand of hydrogens. In 2019, the global hydrogen market is accounted for $136 and $185 million in 2019, where the market is forecasted to grow by 4.3% CAGR between 2020 and 2030. However, due to the COVID-19 pandemic, the hydrogen productions face a negative demand shocks worldwide. This then caused the decrease in the global hydrogen market to 2.4% in 2020 compared to the mean annual growth of 2017 and 2019. Thus, the market is expected to increase from $150.20 billion in 2021 to $220.37 billion in 2028 with a CAGR of 5.6%.
Hello, my name is Muhammad Afiq bin Muhammad Asri. Now I'm going to talk about the process flow diagram and process description. The process flow diagram for biohydrogen dark fermentation can be divided into two stages of anaerobic sequencing batch reactor, or ASBR, which are thermophilic and mesophilic stages. Few extra equipment like circulating water bath, peristaltic pump, tank and gas meter are used to provide the optimum condition for the reaction to occur so we can get the maximum production of biohydrogen. The process of the biohydrogen production from POME is started with purging the nitrogen gas in the reactor first and reactor second to create an anaerobic environment that's suitable for the fermentation reaction. Then, The raw POME that has been diluted with water is preheated to 50 Celsius and fed into the first reactor. The reactor is adjusted at 100 RPM for 96 hours to enrich the cellular biomass content. At first reactor, parameters like pH level and the temperature is controlled to produce thermophilic condition such as temperature equal to 75 Celsius and pH equal to 6.5. The product from the first reactor then will be submitted to the second reactor for mesophilic digestion. At second reactor, the condition of the reactor is adjusted to provide mesophilic condition, which is temperature equal to 37 Celsius. The product of this reactor is flowed to the effluent tank so it can be recorded and analyzed further. The leftover biomass product is recycled into the system. The ASBR thermophilic is used for first fermentation to maximize the usage of the substrate, followed by ASBR mesophilic that will react further with remaining carbohydrate content after the first reactor. After the reaction, fresh POME is released at 85 Celsius and ready to be used during the upscale process in the industrial level.
Hi everyone, my name is Maisara binti Muhammad Yudin. I am going to explain about the result and discussion part. Hydraulic retention time is the average length of time a substrate remains in the bioreactor, and it plays a major role to determine the overall efficiency of biohydrogen production of the system in an ASBR. In this study, our objective is to study the effect of HRT on the hydrogen yield and hydrogen production rate. Table 1 shows the HY and HPR correlation with different HRT in the thermophilic stage ranging from 6 hours to 48 hours. From this table, it is shown that higher HY and HPR are both obtained when HRT is at 12 hours, that is 2.99 mole of hydrogen per mole sugar and 8.54 mole per liter per hour. Table 2 shows the performance of biohydrogen fermentation in the mesophilic secondary stage reactor. Similarly, the highest HY and HPR are both obtained when HRT is equal to 12 hours, that is 1.19 mole of hydrogen per mole sugar and 1.47 mole per liter per hour. Therefore, from this study, we can conclude that the optimum HRT to obtain the maximum HY and HPR in both thermophilic condition and mesophilic condition is 12 hours.
I'm Mindy Chan, and I'll present about the overall efficiency of the two stages ASBR system.
By comparing the hydrogen yield and the hydrogen production rate in the thermophilic condition with the one in the mesophilic condition, we can conclude that the thermophilic condition is the optimum condition as it produces much higher hydrogen yield. So theoretically, an ABSR system that operates under a single thermophilic condition itself would be enough. However, as we can observe, the sugar utilization is relatively low in both the conditions, which means at the end of the reaction phase, there is still a lot of the unutilized sugar in the effluent, therefore reduce the overall efficiency. With that, a two-stages ABSR reactor system is proposed with thermophilic condition in the first stage followed by secondary mesophilic system. Most of the sugar is utilized in the primary thermophilic fermentation, and the remaining sugar available is further utilized in the secondary mesophilic fermentation. In Table 3, we can see that when the two-stage system is introduced, the total sugar utilization has greatly increased for all HRT as compared to the single-stage system. Therefore, the efficiency of the fermentation process has further improved in two-stage reactors, resulting in the increase of hydrogen yield and biohydrogen production rate.
In conclusion, for this study, it can be concluded that a higher efficiency of biohydrogen production can be obtained by using a two-stage SBR system that consists of thermophilic and mesophilic condition, rather than using a single-stage batch reactor system. This is because the two-stage SBR system showed an increment in the total sugar consumption, the removal of TSS, and HPR in comparison with the single-stage batch reactor. Therefore, to conclude, the high conversion rate for biohydrogen production can be obtained by using a two-stage SBR system, and in this study, the optimum HRT for biohydrogen production in both the thermophilic and mesophilic fermentation process is 12 hours. That would be the end of our presentation. Thank you.